Hi guys, welcome again to QSO 520 final project, and we're going to look at problem number 6, and this is goal programming kind of a problem. And let me read the problem itself. So it says Enos Recreational Company would like to increase its profitability by expanding its conventional business. And to do so, the company needs to expand its conference facilities. The company hires a marketing research firm to determine the number and sizes of conference rooms that will be required by the conventions he wants to attract. The results of this study indicated that IRCO facilities should include at least 5 small conference rooms, and this will be 400 square feet, 10 medium 750 square feet conference rooms, and 15 large 1050 square feet conference rooms. Additionally, the marketing research firm indicated that if the expansion consisted of a total of 25,000 square feet, IRCO will have the largest convention center among the competitors, which will be desirable for advertising. While discussing the expansion plans with the architect, IRCO's managing director learned that they could expect to pay 18,000 for each small conference room in the expansion, 33,000 for each medium conference room, and 45,150 for each large conference room. The managing director wants to limit expenditures on the convention center expansion to approximately $1 million. Will you help the manager to attain the goals? So that is the problem. And as I have said, this is goal programming. So why is it a goal programming problem? With goal programming, normally constraints in the model are soft constraints. Remember, we've been dealing with hard constraints, meaning that constraints are limited. For instance, if we have 4 labor, then we are constrained by 4 labor. And so all we can do is either to utilize 4 labor or less. And so that will be the limit. However, with the goal programming, we're not limited with the constraints, but we have a certain goal. For instance, let's say you would like to buy a car and your goal is to spend $1,000. So it doesn't mean that your resources are just 1,000, but you have a goal of buying a car which is $1,000. And so you may find the suitable one for less than 1,000 and you will buy it if you love it. And so you're not spending all your $1,000, but it can be a little bit more than 1,000, let's say $1,100. And sometimes you don't mind paying more if the car looks good. But now it means you can spend a little bit more, or you can also spend less to buy the car. And in that case, you are not limited with the constraints. All you have is the goal. Now, in this case, you can see that the company would like to add at least 5 small rooms. It can get a little bit more, let's say 6 or more. It is not a problem. But also, it may go with less than 5 rooms, which may not be desirable. It is something that can happen. And so the same with 10 medium rooms. The company can get more rooms or less. And the other one also 15 large rooms. It can get more rooms or less. And here you can see that the company would like to have 25,000 square feet, which will make them better than the competitors. However, it can build more than 25,000 square feet or a little bit less. And also we can see that the company would like to spend approximately $1 million. It may spend a little bit more or a little bit less. And since we allowed the fluctuations, then constraints are not hard, but they are soft constraints. So we're going to approach this question a little bit different from what we have been working with the hard constraints problems. Instead of maximizing, minimizing, or getting a desired value, then we are going to focus on the goal itself. So the first thing is, if you can remember, is to start with the model. And we have steps that we're going to follow. So the first thing we're going to do is to define the decision variables. So you can see from this problem that the fundamental decisions are that how many small, medium, and large conference rooms to include in the expansion. And this can be represented by x1, x2, and x3. Those are our decision variables. Now, the second thing that we need to identify is to define the goals. So in this case, we have a number of goals and we are going to define them. So let's look at one goal. We can say goal number 1. And this goal means that we are going to expand our expansion by including at least 5 small 400 square feet conference room. So in this case, the expansion should include approximately 5 small, let me bring this. The expansion should include approximately 5 small conference rooms. So here you can see that we're talking about approximately, meaning that the company can come up with 5 small conference rooms, or a little bit more, or a little bit less. And goal number 2 will involve the expansion in this case, the expansion should include at least 10 medium conference rooms. And goal number 3, the expansion should include 15 large conference rooms. We have another information which says that the company could consider expanding to 25,000 square feet, which will make them to be the largest. And so that's another goal. And we can say goal number 4. And in this case, the company would like to have approximately 25,000 square feet. So that's the expansion. And then we have one more goal. And in this case, it says that the director would like to limit the expenditures on the conventional center expansion to approximately $1 million. And so we can say that's another goal. And this should be goal number 5. So you can say the expansion should cost approximately $1 million, meaning that the company can spend $1 million, or it can spend a little bit more than 1 million, or a little bit less than $1 million. But we must determine if we can find a solution that exactly meets all the 3 goals. If not, then we have to find what trade-offs can be made among the goals to get acceptable solution. Therefore, we will need to define the goal constraints. So let me write it. A goal constraint will show how close a given solution can come to achieve the goal. So we will start with the goal constraints that are exactly to the target value. So to get exactly 5 small, 10 medium, and 15 large, so we can say x1 should be exactly 5, and x2 should also be exactly 10, and x3 should be exactly 15. Then we will use deviational variables to show the approximation of getting of achieving the goal. You can see we were using approximately for all the 5 goals, and so that means we allow some fluctuations, a little bit more and a little bit less. So we will use deviation of variables to these constraints. So we're going to use dn as less than the goal, or in other words, we can say the underachieved, and dp, which is the first one is d negative, and therefore it is less than the goal or unachieved, and dp, which is positive, and in this case we can say overachieved. So the goal can be underachieved or overachieved. So x1, so we're going to add dn, and this is dn1 minus dp1, and this will be equal to 5, and that is for the small rooms. So you can see here we have x1 equals to 5. That is to get exactly 5 small rooms. But here we are adding the deviations, meaning that we may get 5 small conference rooms, or we can get less than 5, or we can get more than 5. And in the case of the deviation, then we are going to add the deviation which is less minus the deviation which is more, which is like a little bit more. And therefore, for the medium size, then we can say we have x2 plus dn2 minus dp2, and this will be equal to 10. And so we have medium rooms. And for the large rooms, we have x3 plus dn3 minus dp3, which will be equal to 15, and those are the large rooms. So let's see how deviation variables work. So suppose we have a solution where x1 is 3, x2 is 13, and x3 is 15. So let me write it. x1 is 3, and x2, these are the solutions. So we assume that we get x1 equals to 3, x2 equals to 13, and x3 equals to, let's say, just 15. So in this case, in terms of deviation, we can see that dn1 equals to, it should be equal to 2, because we are supposed to get 5, but we get 3. So we are getting less than 5, and so we're getting less 2 rooms. And so in this case, the goal is underachieved by 2. So how about x2? We can see that in this case, we are supposed to get, I think, 10. Yeah, here we have 10, but we're getting 13. So in this case, we have more than what we were expecting, and therefore the dp here is 3. dn2 is 0. The same here, dp1 is 0. So we have additional 3 conference rooms than expected. So we can say the goal is overachieved by 3. For x3, we got exactly 15, and so dn3 and dp3, they are all zeros because we get exactly to what is expected. So in this case, we can finish up with the other 2 goals, goal 4 and goal 5. And if you can see, if the expansion consisted of a total of 25,000 square feet, this company will have the largest convention center among its competitors. And so that's another constraint which we can define. And you can see here we're talking of the square feet. However, for the small, we have 400 square feet. Medium, we have 750 square feet. And large conference rooms, we have 1050 square feet. So we can add the constraint as follows. So we can say 400 x1 plus 750 x2 plus 1050 square feet x3. But also we have to consider deviations in this case, and so we're going to add dn, and that is for goal number 4. So dn4 minus dp4, and that is equal to 25,000, and that's the square feet or square footage. And then let's finish up with the other constraint. Here it says that the company would like to spend $1 million, of which we said it can spend a little bit more or a little bit less. And we can see that it can spend $18,000 for each small conference room, and $33,000 for each medium conference room, and $45,150 for each large conference room. And so we can include this constraint here is 18,000 x1 plus 33,000 x2 plus 45,150 x3, and then we will also include deviations, and so we are going to add dn5 minus dp5, and that will be equal to $1 million, and that will be our building cost. So here we have goal number 1, and then we have goal number 2, and then goal number 3, and here we have goal number 4 and goal number 5. So the next item is to define objective. And so so in this case, we're going to look at different outcomes and see which outcome that the decision maker will consider it undesirable, and which outcome the decision maker will consider indifferent. So the indifferent outcome is the one that won't harm the company. The undesirable outcome is the one that is of a concern. For instance, if you look here, X1, the company was expecting to get the small rooms, 5 small rooms, but let's say the outcome comes less than 5 rooms. And so the company will be undesirable, meaning that it has to be of a concern because it requires 5 or more rooms. So if it gets 5 rooms, or let's say if it gets, God of mercy, what is going on here? This is really stupid. So let me, not like that, not like that. So the outcome can be indifferent, meaning that it is not negative or it is not of a concern. So take an example of X2, which is the medium rooms. The company was expecting to get 10. However, it gets 13. And so it has overachieved the expectations by 3 rooms. So in this case, we can say that the company is indifferent, meaning that its expectations were 10 rooms. And so if it gets additional 3 rooms, then that means it is something which is good, but it was actually expecting 10 rooms. So we can say that the outcome is indifferent. Now let's look at X1, which is the small rooms. Now the company was expecting to get at least 5 rooms, but now it got only 3 rooms, and so it is something of a concern because it's not reaching the goal. And so we can say that outcome is undesirable. So if you look at goal number 1, 2, 3, we can say that to underachieve any of these 3 goals, then the decision maker will be undesirable. And those 3 goals are X1, X2, and X3. And the company will be indifferent about overachieving these 3 goals. So what about goal number 4? We can see that the company, if it's able to expand to 25,000 square feet, then it will have the largest conference center, which exceeds their competitors. And so in this case, the company don't have to add more than 25,000 feet because already having 25,000 feet is good. So to get more square feet, then that will be actually undesirable. It's just spending more money for no apparent reason. So for the 4th goal, we can say that the decision maker will consider undesirable to overachieve. And let's say if the company is not able to get 25,000 square feet, or it gets less than 25,000, then that one also we can say the company can consider it undesirable to underachieve. So for goal number 4, both underachieving and overachieving are actually undesirable. Now let's look for goal number 5, meaning that the company would like to spend $1 million as a building cost, and it will spend a little bit more, but that is not what the company desires. It can spend $1 million, which is accepted, but also if it spends less than $1 million, that is indifferent. So in this case, for goal number 5, the decision maker will consider it undesirable to spend more than $1 million, and it is indifferent to spend less than $1 million. Next, we're going to assign weight, and we can assign weight to see how undesirable the outcome can be. However, we don't have to assign weight to indifferent because we are not concerned about it. And so in this case, we will assign the weight of 0 for indifferent, and also we'll assign 1, meaning that the undesirable will be given weight. So in this case, remember, the decision maker will consider it undesirable to underachieve any of the first 3 goals. And so in this case, we will give weight to the deviation, which is n, and so that is for the first goal. And then we will assign weight to the deviation which is negative or underachieved, and so that will be for the second goal, and also it will be the same for goal number 3. However, you can see that the company, if it achieves 25,000 square feet, will be the best in town. So it doesn't have to get more square feet, and so that will be undesirable if it happens. And if it gets less than 25,000 feet, then it won't be the best, and therefore that is also undesirable. And so we'll provide weight to underachieve for goal number 4, and also we will assign weight if we overachieve goal number 4. Now, come to goal number 5. We saw that if the company spends more than $1 million, it is undesirable. But if it can spend less than $1 million, it is indifferent. And therefore, we'll provide weight to what is undesirable, meaning that if the company spends more than $1 million, and so we'll provide weight to the positives or to overspending for goal number 5. And so all this will be given 1. The remainder will be 0. Now the question is, how many weights should we provide to the undesirable outcome? In fact, there is no standard procedure to assign weight, but the company may decide by itself how much weight they should provide to a particular outcome. However, we know that we can assign weight to the undesirable outcome, and we don't have to assign weight to the indifferent outcome because we are not concerned about it. So in this case, we can define our objective function as follows. So we are going to minimize. Now we are going to consider this weight. So it will be WN1, and so now we can define our objective function. The objective function in this case is to minimize the weighted sum of the percentage deviations. Let me write here. So in this case, we can write it as min or minimizing, and we're going to consider this one, which is WN1. And remember, the target is 5, and therefore this will be divided by 5 times so we can write it as minimizing. We're going to start with this one, WN1 times decision, the deviation, which is DN1 divided by 5 plus, we're going to consider this as well. We're going to assign weight to the deviation, which is undesirable for goal number 2. And we're going to look at the percentage deviation. And so that will be times DN2 divided by 10 plus, then we're going to consider the weight for the deviation which is undesirable for goal number 3, and therefore it will be WN 3 times the deviation for that goal number 3, which is DN 3 divided by, so to get the percentage, we're going to divide by the 15, and then we're going to add this one for goal number 4, and so we have WN4 times goal number 4. Remember, we have both undesirable, overachieving, and underachieving, so we're going to consider underachieving first, and so that will be DN4 divided by, and in this case we know that we have 25,000 square feet, and then we're going to add, no, actually we're going to minus overachieving that goal, and so it will be this one here, and so it will be WN4 times deviation positive, and that is for 4 divided by 25,000 square feet. And now finally we are going to add for goal number 5, and so we are going to consider this weight here, which is WP, because that's overachieving. That is the one that we're going to assign weight, times the deviation, which is for overachieving, 5 divided by $1 million. So now the good thing is we have we know the objective function, and therefore I can copy all the constraints and put all of them together. So let me take the constraints that we have already developed. Remember, this is our, this is the first set of the constraints. So let me copy that and put them here. So I can say subject to the number of constraints. We have these constraints. Let's add them. That's the first set of constraints. And then we have another constraint, which will be that the deviations should be greater or equal to 0. And so in this case, we can say deviations, meaning that all the deviations, that will be negative. So deviation negative I, meaning that it can be 1, 2, 3, 4, and 5. And also deviation that is positive for any goal DPI. So I can be either 4 or 5, and all this should be greater or equal to 0. So that is non-negativity condition for the deviations. We don't have negative deviations, but we can have no deviations or deviation. But we'll also consider another non-negativity condition, which is all the x's, so I say xi, should be greater or equal to 0. That's the condition which we can consider. But now we have one more condition, which is xi's must be integers. So these two are non-negativity condition, and this one is integral condition. So this is what actually we have obtained. Then we can use solver to solve the problem. So the next video will be the implementation of this model. Thank you.